Hey! Today we're going to talk about how to find the difference between multiplicative and additive input-output tables. Okay, let's get into it. Okay, let's say we have two input-output tables. We have one right here. Ooh. Oh, dang it. Input. Okay. We have one right here, and then we have one right here. Actually, I'm just going to put I for input and O for output. And we input X and we output Y. Okay, right? Let's say that we input 1, 2, 3, 4 on this one, and we get out, let's say, 6 right here, and we get 7 right here, and we get 8 right here, and we get 9 right here. Okay, let's say I input 1, 2, 3, and 4 here, and right here we get let's say 5 right here, and 10 right here, and 15 right here, and 20 right here. Okay. Well, how do we know which one is multiplicative and which one's additive? Okay. Well, the way you can tell which one's multiplicative and which one's additive is by subtracting. Okay. You can tell if an input table is additive if each one is, if you take the difference between 6 and 1, 6 minus 1 is equal to 5, right? 7 minus 2 is equal to 5. 8 minus 3 is equal to 5. And same thing with 4 minus 9. So they each have a difference of 5, which means that this is additive. That means we're adding 5 plus 1, 6, 5 plus 2, 7. So this input-output table's rule would just be x plus 5. Now let's see if the same thing is true for this one. 5 minus, let's say 5 minus 1 is equal, 5 minus 1 is equal to 4. Okay. 10 minus 2 is equal to 8. Well, that's not the same thing. We already have a problem. Here, the difference is exactly the same. So we know that it's additive because they're adding the exact same number to each one. We have the equation here again. Y, which is output, y represents the output, is equal to x, the input, plus 5. That's it. 1, which is x in this case, plus 5 is equal to 6. 2 plus 5 is equal to 7, so on and so forth. But here, we have a different problem. Here we have a different problem. It's the difference is not the same between them. The difference, it isn't the same between them. Now here, we can check if it's multiplicative. If I keep going, I'll see two things. You'll be able to see two. I'll show you something. 15 minus 3 is equal to 12, and 20 minus 4 is equal to 16. If I were to do this for you, you could see that all the differences here are multiples of each other, multiples of 4. 4 times 1 is 4, and then 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. This gives you a clue that this is a multiplicative input-output table. And we can, instead of finding that, instead of using the difference between them to check, we can divide. We'll divide, instead of subtracting, we'll divide the output by the input. So we can go instead 5 divided by 1 is equal to 5. 10 divided by 2 is equal to 5. 15 divided by, divided by 3 is equal to 5. And 20 divided by 4 is equal to 5. So there we go. So this means that it's multiplicative. We couldn't find, the difference between them wasn't the same, so they couldn't have been additive. The rule couldn't have been additive, but the division, the quotient for them are the same. So that means that this table is multiplicative. That means that we'd have to multiply x by 5 to equal y, the output. Which means that 1, which is x in this case, multiplied by 5 is 5. 2 multiplied by 5 is 10. 3 multiplied by 5 is 15. 4 multiplied by 5 is 20. So if the difference between the input and outputs are the same, then it's an additive. If they're not, then they can't be additive. Then you check the division. The quotient. If the quotient is the same, then the rule is multiplicative. That's how you tell the difference. I say it's cool.